Second video of our circle chapter. Instead of focusing on the outsides of circles with circumference and arcs, now we're going to focus more on the inside of our circles with areas and partial areas. Now, you might know what the area formula for a circle is, okay? Most of you might know it's pi r squared, but why is it pi r squared? How can we derive the formula for the area of a circle? So this is one thing I just want to show you, is one way that you can get pi r squared. You can take a circle and split it up into many pieces like this. And if you alternate the colors here like I did and rearrange them to kind of alternate back and forth, what type of shape does this kind of look like from our past quadrilateral chapter, for instance? Parallelogram! You would be right. You would be right, parallelogram sayer. Good job. Now, what's the area formula for a parallelogram? Base times height. Oh my God, you're on fire. On fire. It is base times height. Now what we need to do is talk about the area, because really we took this whole circle, we split it up, and we made it look like a parallelogram. So the area of this parallelogram is the same thing as the circle. So what we're going to do is figure out, well, the base, this would be the base, right, of our parallelogram. Well, what is that in terms of the circle? Well, that represents all these orange pieces, right? Which, if we go back to the circle, that's all of these pieces here. Well, that's circumference, but it's not the whole thing. How much is it? Well, it's half of it. So the base of this is really half of the circumference. Where's the other half? It's up here with the green pieces. Now the height of our parallelogram was where we dropped straight down and we made a 90-degree angle. Well, what does that represent in our circle? Well, if we go look at our circle, and if I drew that in, well, that would be kind of like that piece, right? And what would we call that in a circle? That would be the radius. So the height is the radius. So base times height, we're really taking half of the circumference, which is the base, and the height is like saying the radius. Now we're going to reconfigure this a little bit. So instead of saying c for circumference, what was circumference equal to in terms of the radius? Well, the circumference was 2 pi r. I could say pi times d, but I'm already using r here, so I'm going to use the 2 pi r version of our circumference, times r. So now, everything in here is multiplication. So 2 times a half, well, it's 1. Really, they knock each other out. What's left behind is pi r times r. Well, what's r times r? R squared. And so there we get the area formula for our circle, is pi r squared. So this first example, we're going to look at calculating the area outside the circle, but inside the square. Leave our answer in terms of pi and round to 2 decimal places. One thing we're going to assume here is that the circle touches the square, that it's tangent to, new vocabulary term next chapter, which means that it touches it at exactly 1 point. Okay? Imagine we have a square piece of paper and we're going to cut a circle out of it. And we're going to have these 4 corner pieces left over that are scrap. That's what we want to find the area of, is the scrap that's left over. Now, I don't really have a formula for finding the area of scrap pieces, but I do have formulas for finding the circle I'm taking out and the square that I originally started with. Now, the square is bigger than the circle, so really in this problem we're finding the area of the square and we're subtracting away the area of the circle. And what's left over is our answer, which doesn't really have a name or a shape or anything. Okay, so area of circle, all right, we just talked about that. That's pi r squared. And I can see from this picture that the radius is 20. So I really have pi times 20 squared, which is 400 pi. And I'm just going to leave it again as 400 pi in terms of pi. But that's how much I need to subtract away. Okay, now I need to find the area of the square. And, well, I would need to know these numbers, right? This is basically the base and the height. And they should be the same, but what are they? What is the base and the height? Huh. What if I drew in another radius right here? And I know that's got to be 20. Well, both of these radii together would make a diameter, which is 40. And so if this is 40, where else could I use that specific value at? Of course, it's hooked. If this is 40, I could just pop this 40 as the base, which is also the height of our square. So the area of a square is base times height, or base squared, or height squared, however you want to refer to it, but it's going to be 40 times 40, which is 1600. So we need to take 1600 and subtract away 400 pi. And some of you, unknowingly, would go, oh, that's 1200 pi. But we are going to treat pi like it's a variable. 1600 is not a pi number. 400 is a pi number. These are not like terms. We cannot subtract them. So what's our answer for the area? Well, it's 1600 minus 400 pi inches squared. And if you want to put parentheses around the 1600 minus 400 pi, you could. Not really needed. Could you simplify this at all? You could, but it really doesn't make sense. I could factor out a factor of 400 from both and be left with 4 minus pi inches squared. Which answer would I write personally? The first one we did. It's just 1600 minus 400 pi. But again, keep in mind, these two numbers aren't like terms. You may not combine them and get a 1200 any way out of that. Round our answer to 2 decimal places. Sorry, forgot about that. If I typed in 1600 minus 400 times pi, where's my pi button? There it is. I get 343.36 to 2 decimal places, inches squared. Next up, what if we, again, wanted to know just part of the area of a circle? Not the full area, but part of it. We're going to need to know the same information we needed to know before for our arc length, or our partial circumference. So a sector is our new vocab term. Sorry, went a little too far there. A sector, the definition of it is the partial area of a circle. Okay? Think of it like a slice of pizza. Sector is a slice of pizza. That's all it really is. It's including the whole outside all the way up to the center. Okay? It's not like you can take your slice of pizza right here and go, hey, look at this. This is a sector. No. It's got to include the center of the circle. Okay? So this, not a sector. This, sector. So sector is the fraction of the area. Well, what's the area of a full circle? Pi r squared. What are we going to do for our fraction? We have to use the central angle again. How many degrees out of 360 do we want of the total area? So again, x is our central angle, or the measure of the arc that we're really referring to. But really, we have another formula here, but it's nothing really radically new, right? I mean, we're just taking pi r squared, and we're just throwing a fraction part in front of it to get our partial area. So for example, 2. If I want to know the shaded area, which is a sector, I need to have x over 360 times pi r squared. And so x in this problem is my 150 degree central angle times pi r is 7, so 7 squared. And let's see, I could divide both these by 10, knocks those out. 7 squared, let's get this. This is really 15 over 36 times pi times 49. There is no factor of 49 that I can cancel out with a factor of 36. So at this point, I'm going to multiply in my calculator 15 times 49, which is 735. And this is all divided by 36. And I'm fairly certain that if I do 735 ABC 36 in my calculator, it gives me 20 and 5/12, which as an improper fraction, oh, it does simplify. What do we, oh yeah, we could have simplified 15 and 36. Duh. We could divide both of these numbers by, ooh, hold on here. There we go. Divide both these by 3, and we'll get 245/12 pi feet squared. That would be my pi answer. And again, most of the time you're just going to leave your answer in terms of pi. Okay? Leave it as pi. Now, from the very beginning, if you don't like, again, dealing with fractions, you could have typed in 150 ABC 360 times 7 squared. And in my calculator, that gives me 20 and 5/12. And if I just press my second button and my ABC key, it's going to convert it over to an improper fraction, which is what will be the preferential answer, which is my 245/12. Then I just have to remember my pi. So it's 245/12 pi feet squared. Okay? So again, you can use your calculator from the beginning, just don't put the pi in your calculator. Example 3, you guys do. Shaded area, sector, notice what's really shaded and what number I gave you here. We'll go over this in class. One more little thing. There's another part of a circle we can find the area of, and it's called a segment. Now, to create a segment, we need to have these lines that's not a diameter. It goes from one side of the circle to another, but it doesn't go through the center of a circle. Okay? The diameter goes through the center of the circle. It is the longest version of what this is called, a chord. Okay? So a line not going through the center of a circle from one side over to the other is called a chord. The diameter is the longest chord that you can possibly have again. Now, the area between the arc and the chord is what's called a segment. Okay? And again, it's confusing. We've already used the term segment, you know? Why can't we just make up a new term? Why do we have to keep recycling and using old terms? So let's talk about how we're going to find the area of a segment. And here I kind of have like shape math, if you will. A segment is really nothing more. If we want to think about this again in terms of pizza, because I think you guys know a thing or two about pizza, primarily cheese pizza, and maybe pepperoni if you're getting crazy, but nothing more than just one topping because that would be just crazy. Area of a sector, really this is our slice, right? This is our whole slice of pizza. And if I were to take that pizza, well, there's two things on pizza, right? There's toppings, there's the good stuff, there's all this good stuff, and then there's this piece, the crust, right? And then this slice of pizza, well, that's kind of a weird piece of crust there, but we can think about crust and our toppings, right? So the piece, the segment we really want is the crust of our slice. Well, we want to eat all the good stuff, right? We want to eat all the toppings, and what shape is our toppings here? Well, it's a triangle. Okay, and if we have our whole pizza, if we eat our slice, and we eat the toppings, what's left is the crust, which is our segment. So the area of our sector, we've already used that formula. That's what we just discussed. The x over 360 times pi r squared, where our x is our central angle. Now, the area of our triangle here, this is a radius and this is a radius. We don't know the length of this piece. The only other number we know, clear this off here, the only other number we know is the central angle, right? This x degrees. So could I use those three numbers to find the area of that triangle? And you're going to have to kind of stretch back and think back a little while. This is a side, this is an angle, and this is a side. Now this has nothing to do with congruent triangles and using side angle side, but we once upon a time had an area formula. It's been a very long time since we used it. But if we knew a side angle side in that order, we could find the area of that triangle. And the area of that was 1/2 side times the sine of the angle. Does that sound familiar? Hopefully, maybe. We just need to replace the s's and the a's with what they represent in the circle. So the two s's are really radii. So we're going to have 1/2 times the radius times the sine of our central angle, which we're calling x. Well, we can simplify r times r. That's r squared. Ooh, did I have? No, maybe not. 1/2. This is r times sine of x. And so we could say this is 1/2 r squared times sine x. So the formula for the area of a segment really isn't a unique thing. It relies on two other formulas. So this is kind of a long formula, but if you think about where the segment comes from, the crust comes from, you can take those two formulas, subtract them from each other to get the area formula for your segment. Okay, so yes, this thing does look a little long and drawn out and crazy, but it's made up of pieces we've already discussed once upon a time. So example 4, calculate the area of the shaded region, which I notice is some crust. We'll say AKA crust. It's really a segment. Okay, so I need to find the area of the whole slice. I need to subtract away the toppings. And that'll give me my crust. My whole slice, that was the sector, x over 360 times pi r squared. I need to subtract away the toppings, which was the triangle, which was the 1/2 side times sine of the angle. Okay, so there's really only two variables here, right? There's x, it's just used twice, and there's r, which is technically used twice. And you know what? We have both of those numbers right here. There's r, there's x. So really this is 150 over 360 times pi times 6 squared minus 1/2 times, really 6 squared, r times r, 6 times 6, times the sine of 150. Now here's the thing, that sine of 150, it's potentially going to throw things off here, okay? There's very few instances of the sine of an angle that's going to give you a number that's decent to work with. So what we're going to do for consistency's sake is just punch all that in your calculator. Give me an answer that is just rounded, basically. We could work with something here, but let's just punch it in. I get 150 over 360 times pi times 6 squared minus 0.5 or 1/2 times 6 squared times sine 150. And I get that this is approximately, to 2 decimal places, 38.12 inches squared for the area. Is there any way we could write this that's not as a decimal, but still could look, mathematical? Sure. Okay. 150 over 360. Let's take this with this piece, kind of bring them together. 150 over 360, and we already did this part, right? We did this problem earlier. Maybe. No. This is 15 pi. Okay, throw in the pi in there. 150 over 360 times 6 squared is 15. There's the pi. I need to subtract away 1/2 of 6 squared. Well, that's 18. Now, if you were to type in sine of 150 in your calculator, it's equal to 1/2, 0.5. So half of 18 is 9. So the area, exact area, no approximating, it's all hooked together. Can we move you now? There we go. Is this? It's 15 pi minus 9, all of that, inches squared. And if you were to type in 15 pi minus 9, guess what you get? 38.12, which is our approximate decimal answer down here. Now, since it didn't say how to leave your answer, which way do you think you should leave your answer as? If it were me, I would go for the exact answer. That's the exact answer. If I really needed to do this in real life, what would make more sense? 38.12 would. Okay? So if it doesn't specify in the directions how to leave your answer, it's up to you. You can go either way. How would I do it? Being the math teacher, of course, I'm going to go with the exact answer versus the approximate answer. And the last example, you guys work on your own. Now, it says calculate the area of the shaded region. Notice what's shaded. It is this gray region here. Okay? Notice this is a segment and this is a crust. I want everything that's not the crust. So we'll discuss that one in class. But I want you guys to try it out on your own before we do it in class. Okay? So that's what I'll be checking.